Yo. So did it work? From what I see here, it maybe didn't. It still shows that that one side is louder than the other one, but it's set to mono. So here it is, channels mono. I don't know how to do this. I'm not nil. So how is it? Does it still have that the stereo problem? Okay, so here there's nothing much here. Okay, dude, you're not responding, so I'm just going to continue this stream. If you click on edit, advanced auto properties. Okay, so let's do this. Edit, advanced audio. Let's see. Don't mix to mono. I mean, oh, so this should be. Yeah, so now it shows both sides are working. So what about now? Better? Now you see that both bars are going at the same time. Now it's working. Okay, nice. Is the 11 out of 10? Oh yeah, boy. Now we have it. Now this is a perfect and 11 out of 10 quality stream right here. Some quality content on the internet. So so thank you, man. I'm really not experienced with this. Thank you so much for helping. This was a kind of long problem with the stream. Everybody was talking about it. I didn't know how to solve it. So thank you very much. I'm not Neil. So your name is not Neil. Now I know your name is at least your name is not Neil. I know that. Thank you so much, man. So what's the idea today? So I have the what is the candidate to be the final idea for the SharkPCB, right? Here it is, and so glad I could help, dude. Thank you so much. So here it is. It has all the features that I wanted to. Finally, I'm so glad that I was able to set them all up. So what's the idea today? Okay, so first of all, we have two main ideas for this PCB, which are, the first one is the what we are calling, when I mean me, I mean me and Steve from Wood Cables, which is the guy that is helping me prototype and will most probably be the proxy on the US. There is also the thread on KiCad. Let me show it to you guys. KiCad. When I switch from the 60 to the 40%, I get all messed up, especially because my 40% is ortho layout, but we are doing it. So, okay, so let's see, SharkPCB, where is it? So here it is. This is the thread on PCB, right? On the SharkPCB. It has a little description of the project and the features we intend to have. It also has this little, video on the project presentation. What I couldn't do, and I'm really bad at this, is putting the renders of the boards here in the thread. But you can check the renders in the GitHub page, which is here, right? So if you go to the STM branch, which is the latest branch, you have a nice high quality render for the PCB. I did this on Blender, right? And okay, so let me open this here, real nice for you. Modulus. In the GitHub page, there are the renders. There are the Blender files. For you guys who don't know, Blender is a 3D modeling and animation program. It's quite nice. It's open source. So if you want to mess around with the renders and see how it works, the files are there. I think I am going also to make a video on how to do high quality renders on Blender. For you guys who want to maybe develop a PCB and make some quality, high quality renders. But as of now, these are the high quality renders, 8K renders. So again, high quality stuff here. Really shiny gold. I mean, this is probably not going to be exactly how the PCB it is. Will be, in the sense that it will be quite shiny. This matte finish is quite expensive to get. You can also have one like this, but the less expensive ones will be the normal solder mask, and it will be shiny, so it will not be this kind of matte finish. There's also the front render here. I am doing a little video. When I am finished, I will do this little video on the board, like hovering around the board and showing the specs and showing the features it has. And when I'm finished with that, I will maybe also do a video on how to animate with Blender, although I don't think, maybe I'll do it, maybe not, because that's not the intent of my streams. It is on PCB prototyping, but anyways, I digress. So there are the renders. If you want to check out those renders, there they are. There are little problems still. So if you have quite a nice look, there is this age 11 here and this age 3. So what are these? These are the KiCad designations for the holes. So if you look here, age 11, there you have it, age 11. So I don't want this guy here. There is really no reason at all for this guy to be here, so I'll just comment this one. KiCad also has what we call comments. Programmers may be more acquainted with that concept. So here are comments. So it will show in blue, but it won't go to the silk screen, so it won't show in the final PCB, right? Also, there is the H3 here. No, where's the H3 guy? Here, H3. Okay, so this is supposed to be the final render, the final board. So what I'm going to do now, right now, I'm going to troubleshoot it, see if everything is connected, see if I didn't miss anything. And in the next step, I am going to do a footprint for the Proton C. For the Proton C. From what I hear, there is a footprint for the Proton C already in the QMP repo, I guess, by Ishtab. Nice guy, by the way, really nice guy. Helped me a lot. But since I am going to use it, I think it will make a nice theme for the board. And before I do that, I want to show you guys how to do logos. So how to insert those nice little logos here, and how was that done. Like this big shark logo here. This big shark logo here, how was it done? And the little SharkPCB logo here. How do you do that? How to add logos? So how what am I going to add today? I'm going to add a little logo of the Brazilian flag. Yes, because albeit of all of its problems, I have still have a little pride in my country. So first of all, to do a logo, you start with a goddamn, that's, don't you hate those like loud motorcycles that pass and don't let you sleep at night? It happens a lot near my home, so it sucks. But you'll get a little template, especially a vectorized picture. I like to use the SVG format, which is the format for Inkscape, which is again open source. You can download it for almost any platform. I think it has for Mac also. It surely has. You can surely get it for Windows and Linux. I'm not sure Mac, but almost sure you can do that. I just need to find. I have prepared a vectorized picture of the Brazilian flag. I just need to get it right here. Where was it now? Let me see. Okay, so I think I will just have to make up a Brazilian flag. I had one done before, but I have to make up a Brazilian flag logo right here, which is not that that difficult. The Brazilian flag is it's really easy to do. So how do we do this? We have here Inkscape, right? Again, open source. You can get it anywhere. Really nice to do. First of all, I'm going to set some little properties. So I'm going to do a grid, right? 1 millimeter by 1 millimeter, no imperial units, sorry. And then I'm going to do this. So I'm going to do the square. The square. Okay, so I'm going to remove the filling and add the stroke. And I'm going to do all black and set something like 0.5 maybe. Yes, 0.5 is nice. Okay, so what did I just do here? So Inkscape has this little tool here, which is for making squares and rectangles, and it also makes round corners, rectangles. So if you take a look here, you can make the dimensions as you want, and you can also make the corners as round or as squared as you want. For this, I'm going to make it pretty square, because the flag is supposed to be kind of square, right? Okay, so and then you have the filling, which is you can add fill in any color you want. So RGBA, no fill for us now, and the black stroke. The stroke is the how can I say this? The outline here. This outline. I'm going to be like 0.5 millimeter. So as it is right now, it is 2 millimeters by 3.5 millimeter thick in the outline. So now I'm going to add a circle, right? So a circle. Okay. So snap here. Nice. So there is this little flag, and then the Brazilian flag, it has these like two lines where you can see the ordem e progresso, which means order and progress and order. Let me show you guys Brazilian flag. Okay, so here it is. So you have the flag of Brazil, right? So you have the square, you have the, how is this called? This is not called rectangle, right? How is this called in English? I have no idea. And then you have this yellow part, and then you have the circle, and then you have this little how can I say this little stroke, I guess. And then that's what we are going to do, the little not square thing, the circle and the stroke. So I have done the flag. It's called a diamond. Really? This format here? Okay, a diamond. So we are going to do the diamond, the thank you again, Neil. I'm not Neil. The diamond, the circle, and the little stroke around it. So the diamond can be done like the same way the flag was done. I mean, here it is. You can rotate it by any angle you want. There you go. And then let's just put it kind of here. No, not yet. There you go. So now we are going to do like this. Here we go. There we go. So now it looks like the flag. See? And then we are going to add the little stroke thingy. So let me see this. So I'm doing this fast because I'm supposing that you have a vectorized font, a vectorized version of the logo you want to put in. I'm just making up one right now, and then little this. And there we go. So we have a little Brazilian flag here. Okay, so now we have a vector version of the Brazilian flag, right? How do we add this to the board, the KiCad board? It's quite simple actually, but it takes some 3 or 4 steps. So first of all, you have to save it. So my thing is not saved, so let's save this. First of all, I'm going to close the page, and then let me save this. So, Shark logo, let's just add Brazil flag. There you go. So I have a Brazilian flag SVG there. Let's just, because I'm a perfectionist, I'm going to set everything the same width, except for these guys here. These two here, let's set them 0.3. So there we are, 0.3, safe. Okay, so now you want to export this to a PNG file. So how do you do this in Inkscape? I don't know the exact button in this in the interface, but I know the shortcut. The shortcut is Ctrl-Shift-E. So this little window should appear, and then you are going to export it. What you should be really wary of is you must add a little white square behind the drawing. I don't know why it is, because but KiCad, when it's importing the PNG, it somehow, some way, it needs the white square behind the drawing. So we are going to add the square. Okay, so fill. I'm going to fill it full with here. I'm going to. Okay, so all of you. God damn it. The actual heck. Okay, so why this stuff keeps... I'm a moron. Let's just redo this. stroke here. No fill. 5, and then a bit more square. And this fill, white filling, no stroke. Okay, so we have the drawing and we have a white square behind it. So now we can export it. What you should be wary of is the pixel per inch, the DPI, because KiCad will ask for that number later. So what you should do is, let me see, resize. Okay. So what size do you want this to be? I mean, as of now, it is 33 millimeters by 25, which is 3 centimeters by 2, which is fairly nice. So see here, so 33 millimeters by 22. I'm going to leave it just like this. 3 centimeters by 2, which is a nice logo size for the board. I'm going to export it as Brazilian flag.png at 1000 DPI. Okay, export. So let's see. SharkPCB logo. So there it is, right? The Brazilian flag PNG. The vectorized part is pretty much done. You can close this now, and then we are going to KiCad. So when you go to KiCad, let me get here. You are going to use this import bitmap here. So let's load the bitmap, and you put the Brazil flag. There you go. So remember, 1000 DPI. By 8000. Okay. Black white threshold. Let's put it at 50. Okay. Border layer, front silk screen. We want to put this on the silk screen, right? There is a way you can do to use this as a like metallized pad, but for now we are going to do this at the silk screen part. Export it, and we are going to export it as a KiCad underline mod file. Let's just do Brazil flag. KiCad underline mod, and there it is, exported. So when you go to the schematic, you can do it both ways, right? So 2 ways you can do this. So you can go here, so place component, add footprint, and then you list all, and then we search for Brazil flag. And there it is. It's quite big because the board is small, I mean. Let's put this, I don't know, here maybe. Maybe we should make this a little bit smaller, but let's just put it this way for the sake of the argument. And then we flip it, because when we flip it, it's going to go to the back layer, and then we are going to move it like somewhere around here. So when we go to the 3D model, there we have it. It's upside down, it's flipped, right? So let's just rotate it. Yeah. Nice. So there it is. What you have to do now is like adjust it to be a little bit smaller. I mean, it looks huge here, like compared to the board, but that's what it is compared to the board. The board is, let's put the right measurements here. So from here to there, So you see it has like 7.5 centimeters by, where is it? We need to get this straight, by 20 centimeters or something. So it is fairly small. The board is small itself, so we need to make the Brazilian flag a little bit smaller, because or else it will be way too big compared to the board. So how do we do this? There are basically two ways, right? We can go back to the right way would be go back to the vector program, Inkscape. Inkscape here, and then we open the Brazilian flag. There we go, and then we shrink it by 1/2. So Ctrl Shift M, scale by 50%. There we go. So now we set the canvas, right? Resize the page. Why resize the page? Because if we don't, the page will be this big. This is the canvas of the page, right? This shadow thing. So there we go. Resize. We saved it, and then we have to export it again. 1000 dpi. Replace, and done. So then we have to update the footprint. So we go here, same shenanigans. There we go. 1000, 8000. I think it is right. 16 by 11. Export, Brazil flag, replace, nice. And then we go to the PCB and update it. Update current. Oops. With current apply. Yep, there it is. See, much smaller. So there you go, much smaller. So this way you can add maybe any. The bitmap converter is a part of KiCad. Yes, it is. When you download KiCad, you have this program here, because KiCad is not a program in itself, in the sense that it is more of suite. I think it will, right? I think the name is suite. I don't know how it is pronounced. I think it's French, monsieur. But it is, KiCad itself is a bunch of programs in the same, is a bunch of applications in the same environment. I think the right word is environment. So you have a bunch of programs, the schematic editor, the symbol editor, which are in the same environment. This guy here is the bitmap converter. So it comes from the from KiCad. It's on the KiCad. When you download KiCad, there it is. So you have a lot of tools here. So here you have, for example, the regulator. You see track width. So this is really important. This is really useful. The spacing for the traces, which I explained in the first video, I guess. So you see the tracks, they have to have a minimum width. Which has to do especially with the current that they are going to need to comport. The temperature rise you want, the resistivity, which is I think 1.72 is the copper resistivity, and the length, which is the maximum length of the traces, and then it calculates the width you have to have. See, for those parameters that are. The spacing between traces, yes, you have to have spacing between traces also. So you have this table for spacing. Most of the time this doesn't bother you. I mean, for us, we are dealing with 5 volts, 5 volt voltages maximum. So maybe some transients of maybe more, like 10, but that's not in discussion here. and you have like these the color code, register color codes. You have these nice tools here. So yeah, make a long story short, the bitmap converter is part of KiCad. There it is. And anyways, you can add anything. How do you make this onto a plated component? So say I don't want to have the Brazilian flag on the silk string. I want to have a shiny golden Brazilian flag, I mean somewhere around here. So how do you do this? There is no really native way to do this. You have to edit the file yourself. You have to edit the file, how can I say this, on the on your by hand. KiCad doesn't have the tool to put this on the copper traces, this design here on the copper traces. What's the problem? The problem is that when you do that, when you want to have a plated design, it will interfere with the tracks. It will interfere with the copper. So, for example, let's say that this Brazilian flag is copper plated. If it's copper plated, let's say it is on the back layer, it is shorting this trace, and this trace. Can you see if it was copper? So you don't want that. You want something that is not tracing, that is not shorting anything, which is quite hard, you see, because the board is full of traces. So it is easier to do on a 6%, for example, that you have the spacebar on there that has lots of free space under the spacebar, and then you can do that. But here it is not as easy to do. What am I going to do? I am going to shrink this Brazilian flag really tiny, so that it can fit, let's say, it can fit here, for example. So if we do this, let's do this, for example, just for the sake of the argument. So we have this little nice space here. We can put a little Brazilian plated flag. So first of all, before plating it and making it copper, go to a copper, I want to adjust the size. So again, I'm going to shrink it to 50% of the size, and then I'm going to update it. So same process, I'm going to do it a little bit faster now. So here we are, Brazilian flag. Nope, not that one, the SVG. There you go. So here you are, same thing, 50%, there you go, and then adjust the page, very nice. There it is, adjusted. And then we save it, export it at 1000 dpi, replace, and then we import it again. Brazilian flag, 1000 dpi, everything looks nice. Export it, Brazilian flag, replace, there you go. And then we update this, okay, there it is. So a little nice Brazilian flag, and you see that if it was copper, it wouldn't interfere with any traces that we have. See, it would interfere. So let's do this. What you have to do is I have prepared this this little text so that I don't miss, because you have to edit it manually. Okay, so apparently what you need to do is you go to the, let me go to Nautilus. SharkPCB logo. There we go. So Brazilian flag. So here we are. So yep, we have to edit this to the layers. So see, what is this? These are the polygon lines for the logo. So what do we have to do? At the end of the line, there is the, you see there is the layer, CF silk, that the logo is put on. So what do? We edit it to f.cu, which is the front copper. So f.cu, and so on. What I like to do is f.silk s and f.cu. So replace all, let's replace, and then we write it. So what have we done? So at the end of the lines here, there is the layer where the polygon lines are located. So if you look here, I have changed it. So before it was written f.silk, which is the silk screen. See, the green lines are the f silk screen here. I have edited them to put them on the front copper, which is the copper pad, and then I saved it. So let's update it again. Apply, close. There we go. See, so now it is on the maybe it is. I think that now it is under the solder mask. Maybe it should be somewhere around here, and it is. I have to just the fill zones don't get automatically updated. So there it is. See, so right now what it is a it looks in KiCad as if it were a copper trace, right? So how do we go from this to a shiny plated hole? So now we edit it in the KiCad symbol footprint library editor. So here we go. So I have here footprint library editor. You open it in the library. There you go. And you just okay. So what do you do now? When you want to add a design as a plated hole, KiCad works in a really, how can I say this, bizarre. I don't think the word is bizarre. I think the word is more of counterintuitive. You have to add an anchor. What do I mean by that? So see, I'm going to make this guy really small. So here S&D size, I'm going to put 0.1. So it's really small, right? So I'm going to do this. So what did I do? You select the pad you just created and the design line, right click, and then you create pad from selected shapes. What did just happen? Why is that 3D viewer not working again? So there you go, see? So that line that we added, it's now plated. So we just do this for every line. We add a second one again, and create pad from selected shapes. This guy, this guy. there you go. So now something fell. So now it is plated. Really, really nice and shiny. So we save it. And then you go back to the PCB and update it. Footprint, update, apply, close, nice. So now you see that it has added these thin lines here. Let me just close my window. Closed. So it added these thin lines here. What are these thin lines? They are the clearance, pad clearance. So when you have two pads, they have to have a little clearance. You can't just, how can I say this? You can't do this, right? See, it has this gray area where the pads cannot, they cannot trespass this gray line. The thin lines here, they're kind of this gray line. So if you add this, this trace here, it cannot go just over that gray line. See? So now it's on the gray line, and that's the clearance. When you go to the PCB 3D viewer, there it is. Really nice, real shiny. And that is how you add the logos to your designs. Particularly, I don't like it where it is right now. Maybe somewhere else. Say, for example, somewhere around here. So, say you do this and you flip, rotate it. And this guy on the front cover just. I have no idea what this is doing here. Anyways, so you just put this here, and it takes some little time to render, and then there it is. It's kind of funny now. I have no idea why. I think that for the back layer, you must do the pad for the back layer. What do I mean by that? Okay, so if you want to add things to the back layer, so now it is on the front copper. If you want to add it to the back copper, same thing. You want to substitute the f.cu with b.cu. How do you do that? Just the fast way. cu b.cu. Replace all. There we go. Save and quit. Write it. Yep. Written. And then again, you open on the footprint editor here, and then you open Brazilian flag. I have no idea why it is here, but anyways, you add the pad. So small pad, SMD 0.1. And then you add to the back copper, right? So there it is. Here, here, oops. You create pad from shapes. So now it is on the back copper. And then you just go on doing that. Let's see here. Then again here. Create pad from shapes. Then let me just delete these little thingies. save, it's saved, and then you update it on the footprint. Update, apply, close, and there you have it. Let me just delete these here, and then this guy, update there. And there we go. On the back plate, on the back cover. So that's how you do it, basically. How you add logos, you do the little shiny logos you see on the fancy boards. That's how you do in KiCad. What you could do different. So if you want the logo to be like really sharp and with real good definition, you just add some DPI. So when you go to the, let's do this again. So when you go to the Inkscape, nice, let's open the Brazil flag. Okay, so when you are going to export it, select, for example, I'm going to do a bit of an overkill here, like 10,000 DPI. Export, it's going to take some time to export. Shouldn't take this long, but okay. Nope, cancel. Yep, and it crashed. Nope. Okay, so no need to kill it. Let's do just like 4,000 DPI, not 10, 4. And export as, let's go desktop, Shark, logo, Brazil flag PNG, export, replace, and then you wait it to export. I mean, if you select like a whole bunch of, not the page, the drawing, yep. If you select like a whole bunch of, let me see, 10,000 here, it's more than 9,000. If you select like a gigantic DPI, of course it's going to take longer, and also KiCad is going to take longer to render it because it is like nicely defined. It's only 1,000, right? Export to 10,000. Yep. KiCad is going to take longer to render it. So how do you do this? Nice. So it is saved. Same thing. Let me delete this. Oh well, KiCad crashed. Nice. And that's how you that's what you get when you tinker with it. And some traces are gone. God damn it. God damn it. Not every little one of them, I mean, damn it. But I'm going to do the flag anyway. So you go to KiCad, and you go to the footprint, and then you open the footprint. Oops, I have to import it before, right? So let's go, load bitmap, Brazilian flag. Okay, so there it is, like 10,000 DPI, and then you export it to the Brazil flag, replace, there you go. Tá fazendo a PCB toda do zero? Não, a PCB ela tá feita já. O que eu estou adicionando agora? Eu estou adicionando umas logos pequenas, então eu estou adicionando a bandeira do Brasil. Eu vou adicionar uma bandeirinha do Brasil bem massa aqui. I was explaining to Dani that we are going to, the PCB is done, it is practically perfected, and what do we want to add a little Brazilian flag to it right now. So let's close this, and then the same shebang, right? So we exported it, and now we want to edit it here. So let's open it, list all Brazilian flag. There we go. So you can see that it is really more like defined here. It has the really sharp edges and the round edges. They are kind of really round. If you want something more defined than this and with more DPI, you can do it. Like you can do 20,000 or 30,000 DPI, but in the manufacturing process, too much DPI is not going to matter. I mean, you won't be able to see it on the naked eye even. Or maybe it won't make really a difference on the fabrication process. So really, like 10,000 DPI gets you a really nice definition. It's a really nice logo, no problems with it. Is it only going to be the PCB, or will it be a complete kit for the GB? Okay, so it can be both. I mean, the GB is going to be the complete kit because the majority of people, they don't want to solder the really tiny little components like the resistors and the diodes and the microprocessor, which is a pain to solder. In fact, the microprocessor, it will be done with professional equipment, with the silk screen technique, with hot air and solder paste. So it won't be done with like a solder iron. Because it can be done by hand, but the chances of damaging the component are really great, are really big, so we won't risk that. Yeah, I will. So you see, if you want to order the PCBs, it's open source. That's why it's open source. If you want to order the PCBs yourself and make like it from scratch, you order the raw PCBs from, say, JLC. I can show you guys right now how to order them from JLC, but I have to finish some these traces here that KiCad crashed, and like screw those traces here. It's going to take just a little 5 minutes, but the chips are best to have done by a machine. Kind of. It will be done manually, but with the proper equipment. See, it will be done manually. Nah, it's fine. It's fine. It's just some few traces. I'm going to redo it right now. So anyway, so I want to create a pad for the back copper. So this little anchor here, I'm going to go to the B base. Nice, and then create that. There we go, and then create that again. So let's just let me just explain to Dani. Dani, então, eu estou fazendo essa placa aqui, que é uma 40%. Eu não sei se você viu, é um layout que a gente chama orto. Qual que é a ideia do layout orto? É que as teclas, elas ficam exatamente retas, né? Num teclado normal, as teclas elas não estão retas. Você vê que elas estão meio de trivela, assim, né? Meio para os lados. Então você tem a orto, que é uma 40%. E o T-Frame 34 aqui perguntou se você vai ter só a plaquinha, porque vai rolar um GB, né? Que é um group buy, que é a compra coletiva. A gente vai ter um GB. Vai ter só a placa ou vai ter a placa com os componentes soldados. Esses componentes da placa, SMD aqui, eles são terríveis para soldar. Eu já mostro eles aqui. Eles são horríveis para soldar. Então, a gente vai fazer o GB, vai vender as placas. Eu vou vender elas no Brasil para quem quiser. Mas elas já vão vir com os componentes soldados. Só o que o usuário vai precisar soldar vão ser as switches, né? E os LEDs, que são THT, né? E, então são bem tranquilos de soldado aí, tá? SMD é um pé no saco na mesma. Sim, SMD é terrível, porque você precisa de um equipamento mais chato para fazer. E eu tenho esse equipamento aqui. Quando você faz em grande escala é tranquilo, né, ter o equipamento. Mas fazer para você não faz sentido, entendeu? Eu vou ter esse equipamento aqui. Mas você vai comprar a plaquinha já toda pronta. Beleza? So, there it is. Plated. I haven't updated the guys here, so let's update them. There we have it. See? Gold, shiny Brazilian flag. A problem that I have noticed here is that the lines of the Brazilian flag, they are thinner than these traces here, which I think are the limit. No, these are, yeah, they can be done, but it would be nice to make this a little bit thicker so that you won't have problems in the manufacturing process. But there you have it, a little shiny Brazilian flag. You can add your country's flag, you can add your little logo. I have a logo for Gondolin Electronics, which is a little tree. Since this is open source, I don't think that I will add this to the project so people don't get it and use it. But in my projects, closed source, there is the Elevate PCB coming, which is a project I'm doing with Felipe Curi, the Mr. Keeps, fantastic guy, and a Teslitron, also fantastic dude. We are doing a 50% wireless board, and it will have a little logo of the Gondolin Electronics. But for now, the SharkPCB will have only the little Brazilian flag there. So now I will, I'm closing the stream, just walking towards the end here. I'm going to show you guys how to order the PCB for, say, on JLC PCB, right? So what am I going to do here? Let me just route this. Here we are. EWM. Here. Okay, so I remember these guys were kind of a little pain. So what am I going to do? I'm going to do this. You are coming around here. Maybe close here. Maybe, yep, here. So, oops, here's better. Here, let's trace this. Let's trace these guys here. So now I can pass over the Brazilian flag here, see, because this is on the front copper and the Brazilian flag is on the back copper. So no worries there. And you. Okay, so let's rotate this guy here. There we go. Okay, so now all that is left is this this trace here. So what am I going to do? I'm going to rotate this. RGB 5 volts. You rotate. Here. Delete that. Acho muito top esses teclados feitos peça por peça, só que não sei desmontar teclado para limpar. Cara, então, é o custom, entendeu? Você, assim, tenta baratear, o massa do negócio é você fazer, sabe? Então o negócio é esse, a gente faz o kitzinho, faz a plaquinha e você monta com as switches que você quiser, com os LEDs que você quiser, você coloca as cores do LED, se você quiser colocar LED cores diferentes no mesmo teclado dá pra fazer, então é bem show, cara. O custom tem essa vantagem, você faz ele, acho que custom, né, tipo o seu. Ok, so let's go over. just one more, and then we are done. So there we go, we have it almost fully wired. Just the third row, god damn it. Let's redo this. Okay, so I'm going just to show you guys how to order it from JLC. I'm going to just leave this as it is and solve it maybe tomorrow another time. Really sucks that KiCad did this on me, but anyways. Yo Pedro, what's up? Nice to have you. So how do you order this on JLC? So first of all, you want to generate the Gerber files, which are the drilling files and the copper trace files for the machining. So how do you do this? You refill, yes, generate, drill, close. So in the SharkPCB, what I did, by the way, was generating those Gerber files. But in the SharkPCB folder, you have this Gerbers folder, and you can just get this all and zip it, make a shark.zip. So what do you do now? You go to jlcpcb.com. And then you go here to quote now, and then you just add the file. Let's wait for the upload. Comprei íris e o USB do Pro Micro, já era. Manda pra mim, cara. Manda pra mim que eu conserto pra você, pô. So here we are. So this is the PCB as it is right now. You see that it has a preview, so you can, when you do the PCB, you can test it to see if the if JLC will be able to do it, if there's nothing wrong with like trace thickness, or if there aren't. You see if they are going to be able to produce it. You go here to analysis results. Okay, you see all green, no warnings, nothing red. So as it is, JLC will be able to produce it. This viewer is quite nice because you can get some kind of renders. So you can render it in, say, black. See, so you can take a look at the final board, and then I mean that's it. You can set the parameters as you want. I mean ship to. So here it is US, but let's put it Brazil. Let's set the currency for Brazilian reais. Save. Okay, you have to add the Gerbers again. So let's add the Gerbers. Sem falar que tô pensando em trocar as switches faz um tempo. Me manda, porra. Me manda que eu troco pra você. Me manda switches, né? Se você quiser que eu compre também, a gente combina. So it is uploading the Gerber files. It takes forever. Nice, there we go. So here you have some nice parameters you can trifle with. So as it is right now, so say you want a green board. So the green board is green with the plated holes and the white silk screen. The red will probably be the white silk screen. The yellow, I'm not sure. I think it is black silk screen. Blue, it is white silk screen. White is black silk screen, and black is white silk screen. As you can see, the price is really dramatically changed by color. So let me set this to US dollars again for our international, guys, so that it is ST2 USD save all. Damn it. Você apresentar até depois, falou bem. Bom apetite. So let's just wait for it to upload. I'll explain to you guys what are these factors here and how they affect your board. So layers are literally the copper layers, how many copper layers your board has. Shark, as it is right now, is a 2 layered board. You can do 4 layers or 6, but if you do a 4-layer board, for example, you see it more than doubles. 6 layers, let's see. So 6 layers, it is ridiculously expensive. Dimensions, you won't change dimensions. The dimensions are imported from the Gerber viewer. Quantity, so you can guess that the per board per unit cost will dramatically fall with how many boards you order. So for example, if I order 5 of them, it's like $14 for 5 of them. It is $2.80. Yes, $2.80 per board. I think it didn't add the shipping there, but it's $2.80 per board. If you want 10 of them, there you go. It's under $2 a board. If you order, say, 100 of them, so it's $1 a board. And if you order, say, let's put something ridiculous here, like 10,000 of them, cannot exceed 50. Please, sorry. Let's say, for example, 1,000, maybe 1,000. We recommend you to prototype the PCBs before small batch PCB production. Yep. So it won't. Goddamn, 56 kilos of board. Imagine that. Anyways, so you can see that it won't get much lower than $1 a board, a buck a board. So if you order 50 of them, say, there you go, something around $1.08 a board. So you can order as many as you want. I mean, it is open source. What I don't, SharkPCB as it is right now, it's not licensed for commercial purposes, which means that if you want to sell it for commercial purposes, you will really need to ask me. I'm not against doing it. I just need to know who is doing it. So if you want to sell it commercially, I mean, buy it to make kits and sell to your community. Please hit me up on GitHub, open an issue on GitHub, or maybe open come hit me up on Discord. Let me see if I have a public invite link to Discord here. I don't think we have a public invite link, although okay, so let me see, there is a link here on the KiCads live stream. Is there? No, I don't think so. But anyways, you can hit me up on Discord, you can hit me up on Facebook, you can hit me up on my streams, and but preferably open an issue on GitHub, and I will willingly give you a commercial use. If you want to order like 10 PCBs, I mean the minimum order is 5, and you won't use all 5, I suppose. So you want to order you plus 2 friends, and you want to order 5. You don't need to hit me up, really. Just order them. If you want to order 10 and share with some friends, that's totally okay. You don't need to hit me up. If you want like to order 100 and start selling it, then please just hit me up on GitHub so I can give you an express authorization to do it. Anyways, PCB thickness. I think the cheapest on GLC is 1.6, maybe not. 1.0, 1.6. Yeah, I mean, you can order anything from 0.6 to 1.6 millimeters thick. It won't change the price, but come on, just do it 1.6. It's the safest, it's the thickest, thick boy, and you will be less likely to have problems. You can also order 2 millimeter PCBs. I think they're gorgeous. I really like the feel of it, but they are really expensive. Again, they more than double. So if you want to order them, no problems. The color will drastically change the price. See, so I think the most expensive one is the white one, maybe. No, the black one. So 34 bucks. Surface finish. So get this. The pads, extra thick, exactly. The 2 millimeter is the extra thick board. It has a really nice feel. I have prototyped some of my boards with 2 millimeters, and some friend of mine who got the prototype said that they sound better when they are 2 millimeters. Particularly, I have never noticed any noticeable, any significant sound profile change. Maybe that's because I tried it on really, let's say, chunky and bulky cases, like the 5-degree aluminum heavy cases. Maybe in lighter cases it really changes the sound. I don't know, but you can also order 2.0. Surface finish. So the surface finish, you have 3 of them, which are this guy Hassel. I'm just going to call it Hassel, lead-free Hassel, and gold nickel. So Hassel, what is this? So the pads, the like that are golden in the KiCad render, see the golden pads, these are the surface finish. So they like submerge the copper, the board in a solution to electrodeposit metals on the pad so that they don't oxidize, so that solder sticks better to them. The best one is the gold one, right? So nickel gold, but it makes it really really more expensive, significantly more expensive. But anyways, Hassel is the silver one. I think it's nickel. Let me check up on that. HASL is, let's just see. Immersion tin. From what I remember, Hassel is nickel plating. Anyways, so ENIC is the gold plating. It is the best one. Remember, gold, it doesn't oxidize, so it sticks better to the solder. Particularly, I think gold. I always order my boards with gold because say you are ordering 10 boards with the Hassel finish, with the silver finish. It is like $2 a board. With the gold finish, it is like $4 a board. It's still quite cheap. So I have nothing against doing the gold one. If you order it with an expensive color, it is like $5 a board. So it's not like that much expensive, anyways. Copper weight. Copper weight is nice. So the boards, they are done. How do they do it? They have this, I don't know how it's called in English. In Portuguese you call it virgin board. It's the FR4, I think it's fiberglass, coated with copper. And then they deposit this on, I think they do it by an optical technique to draw the copper traces on the board. that copper, it has a thickness, a certain thickness to it, and you can order it with 1 ounce or 2 ounces. What does it affect your board? In practicality, almost nothing. I mean, it really matters in the sense that the pads, they get really more sturdier. They get really more resistant to say desoldering, for example. Many people have the problem when you are desoldering the board, the pads lift and you destroy the pad. When you have the 2OZ copper, it is a little bit more difficult to happen. As soon as it's insert switch to it, it's no longer a virgin board. Oh yeah, no it's not. Anyways, panel by GLC-PCB. This panel, you are most certainly not going to use it, but they like group many boards to make it one big making board, so that it gets easier to do. I mean, we don't need it actually, but I've never tested it. I mean, we can do it by I can try it one time maybe. Flying probe test. So flying probe test, they test the board, I mean connection by connection, mechanically with a probe. It's really nice to have because it ensures that the board is working with all the connections it should have. It ensures that the fabrication process was not faulty in any way whatsoever. Castellated holes. We are not going to need this, but you see, they are using as a tool to make more to make openings on the sides of the barrels. We are really not going to use it anyways. Different designs, so you can hire them to do different designs. You are not going to need that anyway. What we are changing basically are surface finish, copper weight, the color, and the thickness, and the quantity, of course. So these are the parameters you need, and that's it. Laser stencil is what we use to solder the components. If you are ordering the PCB in this, let's say, virgin state with no components whatsoever, you will most probably need a laser stencil. What is the laser stencil? It is quite nice. So let's say stencil soldering. Let me show you guys how it's done. So how do we solder those little tiny, literally millimetric components? So we order a stencil. What is a stencil? Let's just see. Okay, so this guy, he has the board here, right? You see the board is, I mean, the footprints are really small. And when you are going to solder, you don't do it by hand. What you do is you order this guy. So you see why it's called stencil, right? It has the small holes where the pads should be. So what does he do? He puts the stencil on the board. He secures the board, and then he puts solder paste. Solder, I don't think this is in English. It's called solder paste. I think it is called how is it called? Solder paste. Yeah, it's called solder paste. So this is basically solder mixed in a paste, so that when you apply it to the board in the stencil, it gets applied only on the places it should be. So he gets a spatula and he just see. So when he takes it out, the solder paste is put just where it needs to be. See, and then you solder it with hot air. So you put the component. See, this component is probably like 1 or 2 millimeters wide. It's really small. He gets his pliers, and then he solders it with, he places them and solders them with hot air. I mean, he didn't do this. Let's just take another video. By the way, I have to give credit to this guy here. Really nice video by him. So Spark Fun Electronics, right now stenciling tutorial, really nice video. Although he didn't actually solder them, from what I've seen, but this guy here does it. So see, so this is a connector. See, these are the solder paste solder paste like sites, and then these big how can I call this? This chunk here is the hot air gun. Again, this is under a microscope, right? This is a resistor. By the way, I think it is just a 1K, 1 kilo ohm resistor. It is like 2 millimeters wide, so this is really small, really small. So he just applies hot air, and then the solder paste will just melt with the hot air. Let me just... There you go, see, it's melting here. And making the connection that we need. See? Soldered. It's now fully soldered. So that's how we do. We need to get either an oven or a hot air gun. Exactly. An oven is it's not needed in the sense that you can have a hot air gun. You can buy hot air guns from AliExpress and whatnot. They are not expensive, but it is quite how can I say this? It takes some time to do. You have to place the components, and then you have to solder them, and then you have to test the board to see if they are done correctly. So it is quite a lengthy process. It sure looks like it's not. It just looks like you have to like put the hot air gun there and just everything gets started automatically. That's not how it happens. You just have to. It's a lengthy process. You get your pliers, you place the components, and then you put the hot air gun, and so it's really quite lengthy. So since not everyone will be willing to do this, in the group we are offering it in the GB like soldered, with everything soldered. Component wise, so apart from the board itself, you will need a bill of materials that you can get from the KiCad. From KiCad you can get a bill of materials. Which component is which? There are the little markings. So if you, let's see, can you go here? Let me just take out the SMD components, preferences, display options, so let's see, this would be the virgin board, right? This would be how you would get the board yourself. See, so you have the markings. So this is the diode 17, diode 18. The circled part, see there is this circled part here, is the it's the negative part. This part here, it's the negative part. So you have all the markings for the components, and you know which components are which. I will add a bill of materials to the GitHub page maybe, so that you can order the components yourself if you want to do them in any way. Let me just check this. Okay guys, so that was it for today. I think that I have shown you how it works, how we are going to do this. The board is, I mean, it was complete until KiCad crashed and I lost some work, but this should take just some minutes to complete, so it should be pretty much done. I have some small tweaks to do here. So you see all the traces, they have this default thickness. I want to add some more thickness to these traces. I mean, so this guy here, I want to do this with a, say, 0.5 millimeter, so that it gets more resistant. See though, so I want to do these kinds of things, small tweaks to the board, but it should work just nicely once I'm finished with it. I will prototype it once I have the money. See, because I'm just I have no money. I'm a PhD student actually, so I'm going to prototype it. It's going to take maybe 1 or 2 months. what's coming from now? So I have finished this version. There is the SMD version. This is what I'm calling the SMD version, me and Steve from Wood Cables. And there we'll also have the THT version. So what's the THT version? The THT version is when you can buy the components yourself, and there will be no SMD components in the board aside from the FET, the MOSFET for the LED, the LEDs. I haven't found a replacement for this guy yet. Unfortunately, it still is the SMD version. It can be soldered manually, but I know that SMD is not the forte of everyone. Unfortunately, I haven't found a THT replacement for this. Maybe I will find it. I think I will just add a 2N7000 or something. But anyways, this will be probably the final SMD version. There is the THT version. The THT version will work with a Proton C. For the Brazilian guys that don't know what Proton C is, Proton C, it's like a Pro Micro with a ARM chip. Okay, so there are these guys. The mechanical keyboard community is not strong in Brazil, so many people don't know the brands and the people working behind it. There is this big brand called the OLKB. They have famous keyboards like the Prionic, the Planck, and the owner of OLKB is also the founder of QMK, and they have developed this little board called the Proton C, which is a kind of Pro Micro, but with the more powerful ARM processor. We will be doing the THT version with Proton C because it's all THT. You won't have any problem soldering it by hand. Some features will not be on the THT version, like for example the fuse. So here is a fuse. Let me show it in 3D. Where is the 3D viewer? There we go. So for example, these guys here, they are meant to be surge protection, right? So this hole here, it should be connected to your case, your metallic case, so that when you have like accumulated static on your hands and on your body, it doesn't go to the PCB, it goes to the USB, and the computer deals with it nicely. These guys on the right here are so the F1 guy here is a fuse. I think as it is right now it's 1 amp. I think I will do 1.5, but it's a fuse. And this guy here is a Schottky diode. It is a regulating diode that doesn't let the voltage surge way too quickly on the board when a surge happens on the USB. These features here, they won't be available on the THT version because I haven't found THT replacements for these guys here. What else? Yeah, I think that's pretty much it. So the Proton C is an USB-C board. It's quite nice. Some of the OLKB boards suffered from surge shorting damage. Yes, there is a little bit of a problem there. I was watching this thread on KiCad. I think I mentioned it on a previous video. I was reading the thread for the M60 on KiCad, and some people have the word is not complained, but they have reported that they are having some problems with electrostatic discharge. When they are using the board, they come from the dry, the air is too dry, or they come to work. When they touch the board resets, or the LEDs just light on and off, or the board shows some odd behavior. That's why I'm adding the ASD protection. You can add it if you want, you can not add it if you want. The fuse is nice. although some people may call me a purist, I mean, I think that as an engineer by formation, I am kind of, I don't know. I just think I needed to put it there as a means of security, you know, to protect the board. Also, some boards have reportedly suffered damage from surge. So there it is. If you are ordering the board yourself, you can not add it if you want. How do you do this with the fuse? You just short the fuse here, and then you add nothing in the diode, this diode here. And then on the surge protection, you just don't solder the components if you don't want it to. Also, there is something that there is not on many of boards, which is the shield protection, right? So the connector, the USB connector. Let me add this guy here. There it is. So the USB connector, it has a shield, right? It has the outer metal part that connects to the shield of the I don't remember if there's the shield or the ground. I think the metal part is the ground, but the cable has a shield around it. What's the shield? It is a metallic net that prevents the cable from being an antenna. Fundamentally, the cable is like this lengthy conductor. It can catch electromagnetic interference, although I don't think it will matter in this lower frequency. I mean, the board works at something around 20 kilohertz. The only high frequency is the crystal at 16 mega, I guess. So it won't be kind of had a problem, but surge can also happen from the shield. You can also have some problems come from the shield. The shield net are these two guys here. This is, I think, a 1 mega ohm resistor, and I think a 10 nanofarad. Let me check on the schematic. Where's KiCad? So here it is. So here's the SMD protection, the ESD protection. Where's the shield protection? Here it is, the shield net. So it is a 1 mega ohm with a 0.7 nano capacitor to, discharge. In the permanent behavior, the steady state behavior is that the capacitor is an open circuit and the resistor is an 1 mega ohm. So it is like visible current here. But when a surge happens, this capacitor, it acts as a short circuit. So all the surge, it goes just right through the shield to the ground, and then the PSU, the power unit on the CPU, on the computer, will deal with that. So it should be nice to have that also. So these are these two guys here. You can add them if you want. You can just not add them if you don't want the shield protection. I mean, it's up to you, but the GB version will have those guys. All the features will be available on the GB. Also, I haven't added a 3D model here. I will add a 3D model for this guy, but the push button here will be also available on the board. As you can see, the push button, it is on the front side. So this is the front side. So the switches will come from up to here. This is the back side, which will be down facing on your desk. This will be the front side, which will be front facing on your desk. This guy here is the push button, and the plate will have a parts list. Yes, of course, you can obtain a parts list from KiCad. I mean, you can have a bill of materials from KiCad. Let me just check that. View. I don't remember how you get the bill of materials. Assign footprint, specific, rescue symbols, symbol fields, schematic. Let me take this. KiCad, bill of materials. I don't remember how to do this on KiCad. Tools, generate bill of materials. There you go. So okay, so User share KiCad plugin. So add plugin. Let me take here because there are some personal files here that I don't want to show you guys, sorry. Okay, so you go to tools, generate BOM, add plugin. So let's go to user share KiCad plugins. Okay, generate. God damn it, the plugin didn't work. Let me see. User share KiCad. Oops. KiCad script plugins. Let's see. Let's just do this. Okay. I'm getting an error here. In module, enum has no attribute. Let's see, HTML. Yeah, it's not generating the bill of materials, but yeah, it will have. Why do you put part in your folders? I don't do. There are some university files that I'm afraid to show you. That maybe I'll just goof out and show you what I shouldn't. But yeah, so it will be the bill of materials will be included as well. No problems there. But for you guys in Brazil, I mean, I'm not Neil and Dani Freitas. There will be I will be doing the selling and the distributing, so you won't have to do that. For Tefren, if you want to do this, are you on the US? You on the EU? Where are you, Tefren? I have a proxy on the US. Steve from Mood Cables will be working as a proxy. If the guys on EU show enough interest, I can do you also USA. Okay, I will have a USA proxy, which will be Steve from Wood Cables. He will be doing all the things, all those things. Also, we will be doing the GB on the US also. So you won't, you will be able to order them directly. Everything soldered, ready for you to just put those switches in and work with them. Okay, guys. So this should be it. I need to go now. Take a shower, sleep, because tomorrow work comes back. Anyways, it was nice having you guys here talking to me. Have a good night. Any more questions? Okay, guess not. Thank you again for the stream. Thank you for watching it, man. This stream will be available on YouTube. I'm still learning to put like the stream chat on my screen. I don't know how to do that, but anyways, I will be doing that. Anyways, good night, guys.